Hi guys, this is a video about the graphs of polynomial functions. I'm making this for my Algebra 2 class. For IB students this is probably not relevant, but it might be interesting to you. Oops, here we go. Polynomials always have the form ax to the n and then different ax to the n minus 1 and different a, etc. They always have this kind of format. The highest power is called the degree. I think in British English we sometimes call it the order, but degree is probably more common usage. The first coefficient at the front is called the leading coefficient, or the coefficient of the highest power. If you've got a even numbered power as your degree, you'll have this kind of U shape with maybe you'll have a bit of a wobble in the middle here, but it'll basically be the U-shaped. That's if A1, your leading coefficient, is positive. If it's negative, we'll just flip that upside down. Okay. If your degree is a odd number, you'll have something like this, maybe a few more wobbles in the middle, but it'll begin down low and finish up high. That's again if your leading coefficient is positive. If your leading coefficient is negative, flip that over, so it'll start up here, go down, wobble around, and then keep going down. These points here are called turning points, but this one we'd call it a minimum. This one's called a maximum, that's a minimum. The plural of minimum is minima. Okay, and this is not the totally lowest point, because the lower point's down here, so it's a relative minimum compared to the things around it. And rather than say relative maximum and minimum, we can say relative extrema. That's the collective term. Okay, now we've got all the language out of the way, let's do some actual questions. So we're going to graph this polynomial here. Quartic. Okay, so we'll plot some points, pretending we don't have a graphing calculator here. Plot some points, and we'll put the points there. Okay, now we know we've got a power of 4. Sorry, whoops. We've got a power of 4, so it's going to basically be a U shape with a bit of a wobble in the middle, so a double U shape in this case. Okay, so it's going to start up here and finish up here. Okay, now here's the important thing. When we go from positive to negative in the y's, and I can illustrate it really easily here, when we go from positive to negative, it's going to cross the x-axis. So there's going to be a 0 or a root of the equation somewhere between -3 and -2. Then it's going to go up here, so there's going to be a root somewhere here, around -1.5. So wherever you see a change of signs in the y, you're going to have an x-intercept. So that's what it's going to look like. What I'm illustrating here is if you had to estimate where the turning points are. If you can see, going from 11 to -9 is a decrease, but going from -9 to 3 is an increase. So it's decreasing and then it's increasing. So it must have turned somewhere around here. So that's, if you don't have a calculator, that's how you guess where the turning point is. You say it's decreasing, 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 then it's increasing, increasing, increasing. So where it changes, that's where the turning point must be. Same here. It's increasing, then it's decreasing, so there must be a maximum there. It's decreasing, then it's increasing, so there must be a minimum in there. Okay, that's all there is to this little theory. Let's do another one. Okay, this time we've got -x cubed plus 4x squared plus 5. Okay, we get our table, we put our points on. Now -x cubed means it's going to start up high, wobble around, and finish down low. Okay, so we're going to go down, up, down. Two important points there. That's your y-intercept and your x-intercept. It's power of 3, so you know there could be 3 x-intercepts, and we can already tell there's probably one about there and one about here, where the signs change. So there's our 3 x-intercepts. Okay. And then we've got our minimum and maximum. Okay. When we see we're going decrease, then increase. Decrease, and then increase. So it's only a small increase, so a bit to the right there, it's going to be your minimum. And then we've got increase, decrease, and increase and decrease are sort of similar amounts, so it's probably around that point where it turns. Okay, that's all. That's all to the theory, right? And remembering negative x cubed, so it has this shape. Okay, one more. This, the way this question is worded is really important. We got to answer the question as it's stated there. So x to the 4, so we know it's got to have that W shape to it. Let's put the points on. Okay, it's going positive, negative, positive, negative. So there's going to be x-intercepts in here. It's going from negative to positive, so there's going to be another x-intercept in there. It's going to start up here. It's going to finish up here. So all that information with x to the power 4 and the change of signs, we can join up the dots, recognizing where it crosses the x-axis. All we have to do to answer this question, though, is say, determine the consecutive values of x between which each real zero of the function is located. Well, there's a real zero there, which is between -2 and -1. There's a real zero here, which is between -1 and 0. There's a zero here, it's between 0 and 1. There's a zero here, which is between 2 and 3. So you just got to list those points. Okay, which I haven't done, but if you, I think you can do that, right? So if you want to answer this question, you have to write between -2 and -1, between -1 and 0, between 0 and 1, and between 2 and 3. Okay, and power of 4, so potentially 4 zeros, and exactly 4 zeros in this case. Okay, so I hope that's useful to think about the way polynomials are shaped. With graphing calculators and with most of the way questions are written these days, you won't come across too many questions exactly like this, but I think this knowledge is still really helpful to have. All right, good luck.